Good afternoon, everyone. So we have the topic of Big Bang Theory. I have to complete this Big Bang Theory topic, and after that, the other batch will join us from 2 o'clock. Okay. So yesterday's class we discussed regarding the seasons, the topic of seasons: polar day, polar night, midday sun, overhead sun, and then so time zones, international deadline, and Milankovitch cycles, daylight saving time, DST. फिर और क्या था? हाँ, we start with the universe. We discuss what is universe, a rough idea of what is universe. ठीक है. So did you write the introduction, definition, universe? ठीक है. ठीक है. Any doubts from yesterday's? It's all clear? ठीक है. Dark matter and dark energy? No, there is space. There is space around us. Okay, so what we know, we are able to see it. There is space around us. It is filled with the bodies, stars, planets, and gaseous clouds from where the stars would originate. Okay, so all such things are there. We can see through them. We can see through the Milky Way galaxy. We can see through the other galaxy. We have that technology, but we don't have the technology to go there. We cannot go there by ourselves. Okay, so because whenever light is coming, we observe those bodies, those space. There is something which cannot be observed by us. That is dark matter and dark energy. Okay, other than this visible matter, okay, so visible matter and the energy which we can feel and experience, there's something which is there in the same area. That is something which is hidden. That is dark matter and dark energy. Okay, so recent estimates have come to a conclusion that that which is not hidden, which is not visible to us, is nearly 95% of the universe. What we are seeing is just 5%. And that too, what we are seeing is the light. When we see the light, there is a time gap. Okay, so let's say you are observing a star, a very distant star you are trying to observe. You are not observing the star on real time basis, it's not live. Because the light which left that star would have taken few thousand years, sometimes few million years to travel itself. So it's like a recorded, okay, so recorded version of what was there at that time we see now. When the light reaches Earth, we'll see that now. The limitation is our capacity to cross this barrier. Our capacity to cross the barrier, that is the limitation. So with the latest telescope in the space, James Webb telescope. It has given wonderful images. Okay, we have never even thought that this kind of images are even possible. It is observing those stars that are located like millions of light years away. You can just observe from here. Of course, we'll not be able to see in more detail. Okay, there is a body. Okay, there may be some planets around that. What is there on that, we'll not be able to see it from here. We'll just see. Okay, so there may be some kind of environment similar to Earth. बस एक्चुअली वहाँ पर क्या है ऑन द ग्राउंड ही पता चलेगा. अर्थ के ऊपर दूर से चांद से देखा तो भी पता नहीं चलेगा ना. वी गेट टू नो द प्रेजेंस ऑफ लाइफ ऑन द अर्थ फ्रॉम द मून. नॉट इवन फ्रॉम द मून इट इज नॉट विजिबल. Leave about moon, from the International Space Station also it is not visible. Right? So the limitation is distance. Any other doubts? So this has been a question which has been a long pending question. Since a long time human beings are trying to answer this question. How did the universe originate? What caused the beginning of universe? What is the origin of universe? Okay, so various different theories are there, philosophical ideas are there. Okay, so in different religions, in different ways they try to explain. For example, in Hindu religion, there are different ideas. Brahma created the universe. Brahma creates, Vishnu balances, Shiva destroys. Okay, so every religion has their own way of explaining things. Okay, some of the philosophy also says that there is no beginning, no end to the universe, na adi na ant. Suna hai? Talking about the modern theories of the origin of universe, one of the most widely accepted theory is Big Bang theory. Other than Big Bang theory, there are few other theories. I'll just give you a rough introduction to them. Then we'll go to Big Bang theory. Okay, first one is steady state theory. Steady state theory was proposed by Fred Hoyle. Fred Hoyle gave steady state theory. Okay, so the steady state theory of Fred Hoyle says that the universe is in a continuous steady state. Same way, no beginning, no end. Okay, this theory is like exactly opposite to Big Bang theory. He was a very staunch opponent of Big Bang theory. Okay, तो इसीलिए ये theory बनाया था. कोई proof नहीं है. Okay, so there is no proof as such to justify this steady state theory. ऐसा ही कहानी बना दिया. Idea. Other than Big Bang theory, क्या ideas है ऐसे rough introduction के लिए चाहिए होगा. Because Big Bang theory says that the universe began with the Big Bang. There was a cosmic explosion. From there, everything started. There was a beginning point. And also the universe is in continuous expansion stage. The size of the universe is continuously increasing. This is the state of universe. That is Big Bang theory. पूरा opposite बोलता है. No beginning, no end. It is in a constant state. And entire size and mass of the universe always remains constant, no change. Universe neither increases nor decreases. Overall size of the universe remains the same. Overall mass of the universe remains the same. Everything remains the same. That same state is what is called as steady state. इसको बोलते हैं steady state theory. ठीक है? सिंपल इतना ही काफी. और डिटेल जरूरी नहीं है. उससे ज़्यादा कुछ इंपॉर्टेंट भी नहीं है. Second theory is pulsating theory. Pulsating theory says a different thing. Pulsating theory was proposed by Arthur Eddington. Arthur Eddington. Pulsating theory says that universe continuously goes in cycles. Cyclical manner में continuously चलता रहता है. Same process repeating. It starts from a single point. Continuously it starts to expand. पूरा एक single point से continuously expand होते जाएगा. Because this single point will explode. It undergoes violent explosion. From there it starts to expand. Okay, so पूरा expand होके maximum limit तक चला जाएगा. Once it reaches the maximum limit, then it starts to undergo continuous contraction. Because during this phase, the explosion had released the energy. That energy caused the expansion. During this phase, the gravity will overtake. Gravity will cause the contraction. Gravity will bring back the entire universe to a single point again. From here again it explodes, again it continues to expand, contract. Like this it goes in continuous cycles. Continuous cycles of expansion, contraction, expansion, contraction. This is what is called as pulsating theory. Pulsating theory tries to bring both of them together. Steady state theory proposed by Fred Hoyle says that universe is in a steady state, no beginning, no end. He also says no beginning, no end. Okay, but Big Bang theory says that there was a Big Bang which caused the expansion, continuous expansion. यहाँ पर expansion होगा, फिर एक time के बाद में वो खत्म हो जाएगा, खत्म होके it will start to contract. Okay, it will start to contract everything and comes back together. And again it undergoes expansion like this. ये है pulsating theory. फिर आता है हमारा Big Bang theory. ठीक है? So we'll talk about Big Bang theory, read about these two briefly. First one, steady state theory by Fred Hoyle. Steady state theory by Fred Hoyle. The overall size and mass of the universe remains constant at any point of time. Next point. The universe has no beginning and no end. The universe has no beginning and no end. Second, pulsating theory. Pulsating theory by Arthur Eddington. Pulsating theory by Arthur Eddington. Universe expands and contracts alternatively. Universe expands and contracts alternatively. Next point. It expands due to explosion. It expands due to explosion and contracts due to gravitational pull. Contracts due to gravitational pull. Next, Big Bang theory. What is this Big Bang theory? universe came into existence through a big bang. It was proposed by Georges Lemaitre. In 1927. It was proposed by Georges Lemaitre in 1927. That time it was just a idea. Okay, so he develops this theory as an idea. He makes it a paper and he publishes it. 1927 he published it. So when he published it, nobody gave any interest. Okay, so कोई भी कुछ ध्यान भी नहीं दिया था ये क्या है कैसे है. By 1930 Hubble's discovery came. हबल पहले भी थोड़ा बहुत बताया था बट एक्चुअली उसका पेपर पब्लिश हुआ था 1930 में 1929 में 1929. So after that it became successful. मतलब it was established. हबल का जो आइडिया था वो एस्टैब्लिश हो गया. Then this guy became famous. But still nobody, not everyone agreed on this. ठीक है. Theory became famous. Finally it was agreed in later in 1960s when the proof was found. Okay, so proof तो 1960s में मिला था और बाद में जाके हमने जब डिस्कवरी करते हैं so regarding the microwave background, cosmic microwave background. Okay, and also when we through Large Hadron Collider experiments, LHC experiments, in recently only in the last 20 years, 10-20 years में जो भी हुआ है उसके बाद में ये फेमस हुआ है. पहले बेसिक आइडिया बता देता हूँ, then we'll see other things. What is the basic idea? What is this Big Bang theory? The Big Bang theory says that the entire universe, everything in the universe, all the space, all the mass, all the energy in the entire universe came from a single point. A single point, which was called as singularity. Okay, so it is not like singularity released all of this. When you think when it is released, you assume there was an empty space and there was a singularity. The universe came out from this empty singularity and filled this empty space. No, it's not like that. There was no space. There was no space, no time, no energy, no matter. There was literally nothing other than the singularity. Other than singularity, there was literally nothing in the universe. No forces of physics, no gravity, no nuclear force, nothing. There was only singularity. Can you imagine the singularity? It's very difficult to imagine. Yep, so how big the universe is? Universe is filled with 100 to 400 billion galaxies, with each galaxy containing 100 to 400 billion stars. Right? That big universe, if somebody is saying that it came from a single point of few millimeter, they said that single point of few millimeters, can you believe this? Nobody would believe this. Okay, so this single point expanded to become universe. It's not like it will come out. Coming out is different. When you say coming out, there was a space, it will come out and fill the space. There was no space also. The universe itself is expanded from the single point to become this big universe from one singularity. What caused this expansion? The Big Bang. The explosion. The explosion of the universe caused the expansion. You know, the explosion of this singularity caused the expansion. Now, what caused this explosion? Nobody knows. We just know that, okay, there was a Big Bang. Big Bang theory begins from here. If you go back in time by 13.7 billion years ago, 13.7 billion years from present, there was nothing in the universe other than the singularity. Okay, there was only singularity, there was no space, there was no energy, there was no mass, there was no time, because our time begins from here only. इसके पहले there was no reference of time. It undergoes, this singularity was made up of all the mass in the universe, all the energy in the universe. It was infinitely dense, infinitely hot. Okay, so imagine 100 to 400 billion galaxies with 100 to 400 billion stars accumulating in this small space. There was no stars and galaxies, of course. I'm saying the matter which came out, the energy which came out, which made all of this, was there in a single point. How dense it could have been, how hot it could have been. It is infinitely dense, infinitely hot singularity. Now this singularity undergoes this cosmic explosion. Georges Lemaitre calls it as cosmic explosion. He doesn't even call it as Big Bang. The term Big Bang came later. Okay, it undergoes cosmic explosion. The explosion was so powerful that it causes this singularity to rapidly expand. The explosion was so powerful that singularity of few millimeter will start to expand rapidly. When it expands, it creates first the space. The expansion creates the space. The singularity, okay, so ये भी पूरा clear picture नहीं है. It expands like this. This is how we can say the expansion would happen. From a single point, it expands so rapidly, then gradually expands. At first, the rate of expansion was very, very high. Rate of expansion was very, very high. How high? In a fraction of second, that is in a time period of 10 to the power minus 30 second. 1 second to pata hai hame? Imagine 10 to the power minus 30 second. In that fraction of second, this singularity expands into 100 billion light years of space. It expands into 100 billion light years of space. That was the intensity of explosion. Okay, the explosion was so powerful that it causes such a rapid expansion. Of course, it is definitely faster than the speed of light. In this fraction of a second, 100 billion light years of space gets created. Energy fills this space. Radiation fills this space. Huge amount of energy. Very, very high temperature. Huge amount of energy, at a high temperature, it fills this space. Other than this radiation, there was nothing in the universe at this point of time. Gradually temperature starts to decrease, because as the radiation gets released, the heat is lost. The temperature starts to decrease. As the temperature starts to decrease, new forces will come into picture. Initially, there were no forces. There were no forces of physics. There was no matter. There was only energy. There was only radiations. As the temperature gradually starts to decrease, okay, so radiations are made up of different type of subatomic particles. Massless particles. Subatomic particles जानते हो? What are the examples of subatomic particles? वो तो बहुत पुराना है, उसको भी तोड़ दिया इन लोगों ने. Okay, they are much further broken into many other particles. Muons, tau, photon, neutrinos. सुना है ये सब? बहुत सारा है. ये सब मिलके बनता है इलेक्ट्रॉन्स प्रोटॉन्स. In those, many of them are massless particles. For example, neutrino. Neutrino recently पता चला है कि उसमें थोड़ा सा मास है, negligible mass है. Earlier, whatever the particles which were there, all of them are massless particles. There was no mass. As the temperature starts to decrease, a particular type of field gets created. Forces of physics will come into picture, right? A particular type of field will get created. In that particular field, some of the massless particles will gain mass. In that particular field, some of the massless particles will gain mass. It will gain mass. They are called as God particles. Why they are called as God particles? That creates everything. If not for them, there would not be anything else in the universe other than energy. Mass भी तो चाहिए ना? Stars, planets, gaseous clouds, satellites. ये सारा कहाँ से आएगा? Mass से आएगा. You need mass. You need matter. Initially, everything was energy. How this energy got converted into matter? We had the theory. We did not have idea. Theory तो था हमारे पास. Theory कहाँ पर था? कौन दिया theory? Einstein. E is equal to mc square. Energy is equal to mass, right? How it will get converted? ये पता नहीं था. How these massless particles will gain mass? इसलिए कंडक्ट किया था एक्सपेरिमेंट्स अलोंग द बॉर्डर ऑफ स्विट्जरलैंड एंड फ्रांस. स्विट्जरलैंड बॉर्डर में एक बड़ा सा टनल बना के दे कंडक्टेड एक्सपेरिमेंट्स टू असेस हाउ दिस मासलेस पार्टिकल्स विल गेन मास. Okay, so they were successful to understand that. They got Nobel for that. Okay, 2010-15 इस टाइम में हुआ था, अभी भी चल ही रहे. Large Hadron Collider experiments by CERN, CERN, right? So उन लोगों ने बाद में, तब तक तो वो बहुत मिस्ट्री था वो कैसे था, अभी रिसेंटली समझ आए. That happens. The massless particles will gain mass. Once mass come into picture, gravity comes into picture. Gravity comes into force. Mass will attract mass because of gravity. Now these subatomic particles will merge together to form these electrons, protons, neutrons. Now all of them merge together to form atoms. Now atoms will merge together to form molecules. All of them come together because of gravity, forms a huge gaseous cloud. Now because of the same gravity, they will start to collide with each other. There is a friction, there is a release of heat, then continuous release of heat forms the star. Stars will originate from this gaseous cloud. Around the stars, planets are originated. ये तो बहुत सिंपल है, समझना तो बहुत easy था. But ये समझना बहुत मुश्किल था कि how the energy will get converted into matter. बहुत टाइम के बाद में वो सॉल्व हुआ था. That will also become one of the proof of Big Bang theory. There was a singularity. It underwent cosmic explosion. Because of the explosion, the rapid expansion started. Rapid expansion of the space. Huge amount of energy fills the space. Now this energy gets converted into matter. In a particular field, particular type of particles only gets converted into matter. They gain mass basically. That field is what is called as Higgs field. The particles which gain mass, they are called as bosons. Higgs bosons. They are called as God particles. Bosons are named after Indian scientist. जानते हो, सुना है कहीं पे? साइंस एंड टेक्नोलॉजी. ठीक है, थोड़ा सा कवर होगा ये सब चीजें साइंस एंड टेक में. To understand this, the people who did this experiment, they had to recreate the conditions similar to what existed after Big Bang. Big Bang के बाद में जो condition को recreate करना था उनको. What was the condition in this at this point of time? Temperature was very high, a very high temperature, and the particles were highly energetic particles. You have to understand them. उनके लिए ऐसे वाला condition create करने के लिए what they did, they made a huge tunnel, circular tunnel बनाए. Okay, so बड़ा सा circular tunnel बनाया, and in that they released these particles and they accelerated them. वो भी underground बनाया था because they don't want to have any kind of interference. दूसरी particles का interference नहीं होना चाहिए. They had to accelerate this. Okay, so there is particle accelerator. पार्टिकल एक्सीलरेटर यूज करके उसको एक्सीलरेट किया पूरा कंटिन्यूसली, इसलिए तो सर्कुलर टनल चाहिए ना, उसको कंटिन्यूसली घुमाते रहो घुमाते रहो घुमाते रहो, एक पर्टिकुलर हाई फील्ड में वो स्टेट अटाइन होगा जो बिग बैंग के बाद में जो स्टेट था. नाउ वी कैन अंडरस्टैंड देयर बिहेवियर एंड दे वर एबल टू रिक्रिएट दोज थिंग्स. They were able to recreate those conditions. Higgs field आया, फिर bosons will gain the mass. They were able to prove that. जब ये सारा एक्सपेरिमेंट हो रहा था तो एक छोटा स्केल में बना के फिर बोला है कि हमें अभी बहुत बड़ा सा टनल चाहिए, ये काफ़ी नहीं है, तभी होगा. So people were afraid. इतना बड़ा टनल है कि it goes in kilometers. वो भी एल्प्स माउंटेन्स के नीचे. Okay, so बहुत पैसे लगा के बनाया था. People were afraid. Why they were afraid? इनके एक्सपेरिमेंट के चक्कर में दोबारा बिग बैंग हो गया तो नहीं हुआ. Okay, so they got Nobel for this experiment. So they were able to prove. अभी उससे भी बड़ा टनल बना रहे हैं. अभी तो पक्का डाउट है हो जाएगा. So that happened here. Okay, so the particles which are massless particles will gain mass. From these mass particles, subatomic particles, the atoms, the lightest atom being hydrogen, helium, will come into existence. And because of the mass, because of the gravity, they will start to come together. They form gaseous clouds. In the entire meantime, the space is continuously expanding. The space continuously expands. It is expanding even now. The rate of expansion is low, but it is still expanding. What is causing the expansion? The cosmic explosion. Explosion release radiation. Explosion cause the expansion. This radiation will change its nature. It will gain mass. Okay, that results in the formation of various bodies. That is how the universe came into picture. Okay, these bodies in the entire universe, they are all moving away from each other. That means the universe is continuously expanding. That is the idea of Big Bang theory. Who gave this idea? Georges Lemaitre. When Georges Lemaitre gave this idea, nobody even gave. ये तो simple सा paper था. After 1920, in 1929, Hubble publishes his paper. Then he becomes very famous. Hubble का idea था कि every star and galaxy in the universe, they are all continuously moving away from each other, as well as Earth. They are moving away from each other as well as from us. Okay, therefore the universe is expanding. Hubble ये बोला था. So everyone agreed because he gave it data. Then everyone agreed, including Einstein. He had to change his theory of relativity. Okay, so Hubble के पहले एक theory of relativity, उसके बाद में एक theory of relativity. General special है ना, दो है. Everyone agreed and they accepted because before that the idea was static universe. Static universe, there is no change in the universe. Universe always remain the same. Size and mass of the universe remain the same. ये idea था. Now comes the idea of dynamic universe with Hubble. Everyone agreed on Hubble. तब ये बंदा दोबारा बोला, देखो मैंने तब भी बोला था, आप लोगों ने नहीं सुना है मेरा. फिर अपना पेपर लेके आके दिखाया, देखो 1927 मैंने पब्लिश किया बिफोर हबल. So then, like, ठीक है, so they agreed. Then still the question comes, what is the proof that the universe is expanding because of Big Bang only? What is the proof that Big Bang had happened? Expand हो रहा है, हबल तो बोल दिए, प्रूफ भी दे दिया, वो ठीक है. बट बिग बैंग हो रहे, बिग बैंग हुआ था, इसका क्या प्रूफ है? बहुत आगे जाके 1960s में इसका एविडेंस मिलेगा. तब तक तो दे नो दैट दिस इज ए थियरी, बट ऑल्टरनेटिवली बहुत सारे थियरीज आ जाएगा विच विल इंक्लूड द एक्सपेंशन एस्पेक्ट बट नॉट बिग बैंग एस्पेक्ट. फाइनली इट वाज प्रूवन दैट बिग बैंग हैड हैपेंड. एंड इनिशियली एज आई टोल्ड यू देयर वाज नो आइडिया ऑफ बिग बैंग, देयर वाज नो टर्म ऑफ बिग बैंग ओनली. Okay, so Georges Lemaitre called this as expanding universe theory. Who coined the term Big Bang? Fred Hoyle. Fred Hoyle was the most staunch opponent of Big Bang theory, right? His greatest contribution is coining the term Big Bang. And once it happened that in a radio interview, he was talking, he was criticizing Big Bang. ऐसे नहीं हुआ है, लोग ऐसे बात करे Big Bang हुआ है, Big Bang हुआ है, ऐसे कुछ नहीं हुआ है. There was no Big Bang as such. लोग बोल रहे हैं कि एक्सप्लोजन हुआ है जिसकी वजह से एक्सपेंशन हो रहा है. Okay, so all of these are talking about the explosion. There was no such cosmic explosion. There was nothing of that sort. There was no big bang. That is what he said. ये जो बोला वो सब भूल गया, बिग बैंग को पकड़ लिया लोगों ने. ये वर्ड अच्छा है, चलो इसको बिग बैंग बोलते हैं. From then it became Big Bang theory. The term was actually given by Fred Hoyle. Okay, so write about this. So we'll talk about Hubble and cosmic microwave background also. Okay, उसके पहले लिखो. Big Bang theory proposed by Georges Lemaitre. In 1927. First point. The universe was once an extremely compact dense and hot singularity. Extremely compact, dense and hot singularity. Stop. There was no other matter. There was no other matter or space or time existed. Next point. 13.7 billion years ago, a cosmic explosion occurred. A cosmic explosion occurred, known as Big Bang. From that time, universe started to expand. From that time, universe started to expand and is still continuing today. And is still continuing today. Next point. The expansion subsequently led to the formation of forces of physics, elementary particles, atoms, molecules, gaseous clouds, stars and galaxies. Stars and galaxies. ठीक है? This is Big Bang theory. आपका कौन सा बैच है? 37. यहाँ तक हुआ है. इसके आगे कुछ लिखा है? ठीक है. आपका कौन सा बैच है? ठीक है. ठीक है. बाकी लोग अभी ज्वाइन करेंगे. We'll continue after that. So did we discuss Hubble's? हमने हबल का बात किया था क्लास में. बात हुआ था. बात हो गया था. लिखना है पक्का. हबल का बात हो गया. कॉस्मिक माइक्रोवेव बैकग्राउंड का बात हुआ था. हबल का बात हो गया. चलो हबल को बता देता हूँ. I'll dictate once they come. So what was Hubble's hypothesis? Hubble in 1929 gave his publication. He published a paper. In that he gave this idea that all the stars and galaxies which we can observe in the night sky all of them are actually moving away from us. This is very simple. Hubble का idea तो बहुत simple है. Any star, any galaxy you see in the night sky, all of them are actually moving away from us. The distance between us and them is continuously increasing. Not only this, even between them, the distance is continuously increasing. The stars are basically moving away from us. This is his theory. He will not say, तो Big Bang हुआ था, नहीं हुआ था, क्या कारण है इसका? He will not say anything. Just say, the universe is continuously expanding. Because if they are moving away from us and if they are moving away from each other, that means the space is expanding. Okay, so that is the only hypothesis, right? Only logical conclusion you can make. Okay, so in NCERT there is a balloon experiment. Right? You take a balloon, you mark some dots on this balloon and you start to inflate the balloon. As you inflate the balloon, the dots will start to move away from each other. That is how the universe is expanding continuously. And since they are moving away from each other, from every point they are continuously moving away from each other, that proves that universe is continuously expanding. Okay? Now, on what basis he came to this conclusion? Before that, we have one important doubt. What caused the explosion? What caused the Big Bang? Okay, so there was a very famous professor, a very famous astrophysicist. Okay, so he used to teach in a very famous university, Oxford या कुछ भी तो था, ठीक है? And outside his chamber there was a board. उसके chamber के बाहर एक board लगाया था. उस board में लिखा था, if you are here to ask what caused Big Bang, what was there before Big Bang, please don't enter the room. Because nobody knows. So nobody knows about this. Our Big Bang theory starts with the Big Bang. Okay, it starts with the Big Bang. What is before? What caused this explosion? Nobody knows. उसका बिल्कुल idea नहीं है. ठीक है, coming back here. So on what basis Hubble came to a conclusion that every body, every star, galaxy is moving away from us and from each other? It's a simple idea. The way we have this Doppler effect. Okay, so sound का जो effect होता है ना, fine. So if any body is moving towards us, the intensity of sound increases. The intensity of sound increases. So let's say an ambulance is coming towards you, so intensity, uska jo siren ka intensity increase hote jayega. You can very clearly see. You are not able to see the vehicle moving, but you can still feel that yes, it is coming towards you. If it is going away, the intensity decreases. You don't have to see it. Just by the sound only you can come to this conclusion. The same phenomena can also be observed in the case of bodies which are producing light. Okay, so here the intensity of the sound increases and decreases. In case of the light, the wavelength of the light will increase or decrease. Okay, so for example, if this is the body of light which is producing light, and this is the observer, यहाँ पर आप खड़े हैं, तो यहाँ से आप देखने की कोशिश कर रहे हो. If this body is producing a light in a particular wavelength, wavelength तो जानते हैं, the distance between two crest and trough. It is producing the light in a particular wavelength, एक particular wavelength में आ रहा है. If this body is stationary, the wavelength always remains constant. Same wavelength में आएगा. If this body is stationary, if the distance between them is not changing, the wavelength remains the same. ठीक है? If this body starts to move towards the observer, यहाँ पर observer है, it starts to move towards the observer. The wavelength decreases. The wavelength of the light will start to decrease. ठीक है? ये तो fact है. जैसे intensity increase होगा, पास में आते आते wavelength decrease होगा. If this body moves away from the observer, the wavelength will increase. The wavelength will decrease if it moves towards the observer. The wavelength will increase if it moves away from the observer. ठीक है? What happens when the wavelength decreases? The color of the light changes. Wavelength अगर change कर लो, color change हो जाता है. Because normally visible light में जो color होते हैं, हमें पता है 7 colors. विप गया. Center में जो है moderate. You go towards the higher wavelength, it becomes reddish. It go towards the lower wavelength, it becomes bluish. सबसे lowest wavelength में आपको मिलेगा वायलेट, इंडिगो, ब्लू. हाईएस्ट वेवलेंथ में आपको मिलेगा येलो, ऑरेंज, रेड, सेंटर में ग्रीन. ठीक है. if anywhere if you are increasing the wavelength increase करो, the color changes towards the red end. मतलब यहां पर है वेवलेंथ इंक्रीज करो, ब्लू होगा, ब्लू से ग्रीन, ग्रीन से येलो, येलो से ऑरेंज, ऑरेंज से रेड. If wavelength decreases, it shifts towards the blue end. If you are here yellow, yellow से green, green से blue, blue से indigo, indigo से violet, shifting towards the blue. If you are seeing the color is changing towards the blue, what do you mean by that? The body is moving towards you. That phenomena is called as blue shift. If you are seeing blue shift in any body, that means the body is coming towards you. The light from a body is continuously becoming bluer, bluer. पहले green आ रहा था, अभी थोड़ा सा bluish होते जा रहा है. That means wavelength is decreasing. Wavelength decrease हुआ तो blue की तरफ में जाएगा. If you see that any body which is producing light is producing the light which is becoming redder. पहले ग्रीन था, अभी येलो हुआ है, थोड़ी देर के बाद में फिर ऑरेंज हुआ है, फिर रेड हो रहा है. इट इज शिफ्टिंग टुवर्ड्स द रेड एंड ऑफ द स्पेक्ट्रम. दैट मीन्स इट इज मूविंग अवे. If you observe blue shift, the body is moving towards you. If you observe red shift, the body is moving away from you. Hubble used to observe these stars for a very, very long period of time. Made continuous observation. In every star, every body he observed, he always observed red shift. He never observed blue shift. He always observes red shift. That means every body of this universe is moving away from us. Okay, so each body of the universe is moving away from us continuously. That means universe is expanding. He even calculates, he collects the data so precisely, he is even able to calculate the rate at which this body is expanding. These stars are expanding. That is what is called as Hubble's constant. The rate of expansion of universe is Hubble's constant. ठीक है. दिस रेट ऑफ कोर्स वाज वेरी वेरी हाई इन द बिगिनिंग. अभी तो हमारे टाइम स्केल में तो ये कांस्टेंट है ना. राइट नाउ इट इज कांस्टेंट. ठीक है. दिस व्हाट इज हबल्स हाइपोथेसिस. बेस्ड ऑन दिस वी कैन कंसीडर, ओके, इफ यू लिंक बोथ ऑफ देम, ऑब्वियसली बिग बैंग की वजह से ये हुआ है ना. यू कैन से सो, बट देयर वर फ्यू अदर हु से बिग बैंग कुछ नहीं हुआ था. ये तो एक्सपेंशन तो नॉर्मल प्रोसेस है. पल्सेटिंग थियरी भी बोला था एक्सपैंड हो रहा है ना. इनफैक्ट स्टडी स्टेट थियरी में भी एक्सपेंशन लेके आ जाते हैं वो. ठीक है. तो बिग बैंग का एक्चुअल एविडेंस हमें मिलेगा थ्रू कॉस्मिक माइक्रोवेव बैकग्राउंड. ठीक है. सो दैट विल सी. चलो 5 minutes का ब्रेक क्विकली. लेट द अदर्स कम, देन विल कंटिन्यू. या सो ऑल ऑफ यू आर हियर. सो RB1 2026 RB1 है. ठीक है. 37. So there was one topic pending, that's why I called you late. तो हो गया. Now we are at par. I think so हमने last discuss किया था regarding the Big Bang theory and Hubble's idea of expansion. Hubble का नहीं हुआ था, dictate नहीं किया था, बात कर लिया था. तो बताइए, आप बोल रहे थे हबल का बात किया था. चलो कोई बात नहीं, दोबारा बताता हूँ, ज़्यादा कुछ नहीं. So what was this idea of Big Bang theory? Big Bang theory says that there was a singularity which undergoes cosmic explosion. The cosmic explosion of the singularity causes the expansion. As the singularity expands rapidly, the energy which had filled the space, some part of it will get converted into mass. Okay, so under specific conditions which exist just immediately after the Big Bang, this happens. This energy and mass which is there in the space, which has filled the space, gradually evolves and the space continuously is expanding. As this expands, the matter and energy together, it forms various different bodies. Subatomic particles forms atoms, atoms form molecules, molecules form gaseous clouds. Within the gaseous clouds, due to the continuous interaction, the heat production, the stars are originated. As the stars originate, around that planets will also originate. We'll talk about the origin of stars and planets separately. Okay, briefly बता रहा हूँ अभी. So And because of the explosion, the universe expanded, and it is still expanding today. So it is a continuous state of expansion. That is why this is called as the expanding universe theory. Okay, this idea was given by Georges Lemaitre in 1927. In 1929, Hubble comes and gives his idea that every observable star and galaxy in the universe, they are continuously moving away from us. They are continuously moving away from us. Okay, this is his observation. Not only from us, they are also moving away from each other. Okay, so this continuous expanding observation is made by Hubble, and he also calculated the rate at which they are expanding. That is called as Hubble's constant. Okay? On what basis he did that? Through the phenomenon of redshift. What is this redshift and blue shift? Whenever a body which is producing the light moves towards the observer, if a body is moving towards the observer, the wavelength of the light increases. The wavelength of the light. Okay, so let's say the body is stationary, it is not moving. Okay, the body is stationary, it is not moving. The light is constantly coming in the same wavelength, and wavelength will decide the color of the light. The light's color remains constant. If you are observing continuously a light source and the color of the light remain the same, that means the body is stationary. Okay? If this body starts to move towards you, what happens to the wavelength? Wavelength decreases. Okay, the wavelength decreases. If wavelength decreases, the color of the light changes, because color of the light is dependent upon the wavelength. Higher wavelength is usually redder in color, lower wavelength is bluer in color. In the WebGyre, blue is towards the low wavelength, red is towards the high wavelength. In between is green. So green to yellow, yellow to orange, orange to red is higher wavelength. Green to blue, blue to violet, blue to indigo, indigo to violet is towards the lower wavelength. If the color of the light is gradually becoming reddish, that means wavelength is increasing. If the color of the light is gradually becoming bluish, the wavelength is decreasing. If wavelength is decreasing, the body is moving towards you. Only in that case the wavelength decreases. If wavelength is increasing, the body is moving away from you. If any light source, let's say you are observing a star continuously, and the wavelength of that light coming from the star remains constant. If it remains constant, that star is also constant. The distance between you and the star is constant. If the wavelength of the light is increasing, the star is moving away from you. If the wavelength of the light is decreasing, the star is moving towards you. How will you find out wavelength is increasing or decreasing? Very easy, observe the color. If you continuously observe the color, if the light color is changing towards the blue end, whatever the color, initial color is, it is shifting towards the blue. If it is orange, orange becomes yellow, yellow becomes green, green becomes indigo, like this, shifting towards the blue. That means the body is moving towards you. The wavelength is decreasing. If the color of the light is shifting towards the red end, that means like from blue, blue to indigo, indigo to green, green to yellow, yellow to orange. If it is shifting towards the red end, that means the body is moving away from you, because the wavelength is increasing. When Hubble did his observation, he found out that everywhere the bodies are moving away only. Everywhere he observes only red shift. He never observes blue shift. Blue shift is never observed in the universe. There are only few rare occasions, only then you will observe the blue shift. Otherwise, it's always red shift. Okay, it's because of the red shift you can come to conclusion that every body in the night sky is moving away from us. How is that every body is moving away from us? How is it possible? One body maybe yes, another body maybe yes. But how is it possible that everything is moving away from us? Hubble will not say anything. If you bring both of them together, you can very clearly come to conclusion. Big Bang had happened. The space is expanding. The universe is expanding. Right? That is the idea. That is why Hubble's idea can be considered to be one of the support for Big Bang theory. The actual evidence will be given by the discovery of cosmic microwave background. ठीक है, तो वो हम बात करेंगे हबल के बारे में लिखे. Hubble's theory. Hubble in 1929 Hubble in 1929 proposed that all observable stars and galaxies are moving away from the Earth are moving away from the Earth. Next point. He discovered this through the phenomena of redshift. He discovered this through the phenomena of redshift in the light coming from stars. In the light coming from stars. Next point. The rate of expansion is called as Hubble's constant. The rate of expansion is called as Hubble's constant. So next subheading, cosmic microwave background. Cosmic microwave background, CMB radiation. Bracket में can write CMB radiation, cosmic microwave background. तो इसके बारे में तो डिस्कस नहीं किया है ना? Did we discuss this? It's a very interesting story. So in 1927 Georges Lemaitre gave his idea. 1929 Hubble's idea came out. Then it became very obvious. Yes, there is an idea called as Big Bang theory. Everyone had come to know about this. But it was not very clear whether Big Bang is the reason behind the expansion. Expansion is happening. The universe is expanding. Before that, there was an idea of static universe. With the Hubble's discovery, it became a dynamic universe. It is an expanding universe. Universe is not static. ये तो establish हो गया. Now, what is the proof that Big Bang had happened? Because many other theories will also come and they also justify the expansion, and they don't bring the idea of Big Bang at all. There are many theories will come into picture. Many people will start to work on this. Okay, so people will like they're given time of their lifetime, like 30 years, 40 years on this research. They're yet to find any kind of evidence to prove Big Bang. Okay, so there was one professor who had given nearly 30 years of his research on this idea. He could not find the evidence of Big Bang. He was working in one of the university in USA. Okay, so accidentally, so nearby, in the same place nearby, two amateur radio astronomers, they were making some experiments. They were doing some experiments. Who is a radio astronomer? Observer of space using radio waves. Okay, so they use the radio waves. Okay, so by observing the radio waves from across the different parts, they try to do some calculation and try to do things. So they had a receiver, antenna receiver, and they're trying to receive a particular wavelength of radio waves. Okay. And they were doing in this a desert area, a dry arid area. So, and their experiment was to collect certain particular wavelength of radiation. Whenever they're trying to collect a particular wavelength of radiation, in the background there always used to be a noise. In the background, They are trying to receive the signal, a particular signal they are trying to receive. In the background, there is always a noise. A noise radiation is continuously being observed. Okay, it's like a buzzing noise. Okay, which we see when we have a disconnection in the dish TV or cable. Okay, जब केबल चला जाता है ना, तो तब तो वो background noise आता है ना, buzzing noise. The same kind of buzzing noise they used to receive in the antenna. So they thought there is some issue with the signal, so they will change the direction of the antenna. Okay, from here they will change. Here also it is coming. The third direction, here also it is coming. They shift the antenna only. They take the antenna to a different place. There also it is coming. In that particular wavelength, they always receive this background noise. Okay, they thought, आज का दिन ही खराब है, चलो कल आते हैं. Okay, so they will come tomorrow, day after tomorrow, next week, next month. Continuously you go to any part of that area, so everywhere you are receiving that background noise. Finally they come to a conclusion that there is a issue with the antenna. Okay, so iske pehle they try to understand what is causing this issue. So they would think that जहाँ पर एंटेना रखा है ना, वो पेड़ के नीचे रखा होता है, तो वहाँ पर एक पिजन का नेस्ट रहता है. They thought ये पिजन ने कुछ छेड़छाड़ कर दिया. Okay, so they will try to chase away the pigeon. It is not going away. They will kill the pigeon. फिर भी नहीं हो रहा है. Finally, tired of this, they will go to this professor who was working. Okay, in that university he was there. No, see, they goes to this professor. They say, we are doing this experiment, and please correct this antenna. इसको ठीक करके दे दीजिए please. ये खराब हो गया है. Okay, they will try to explain. हम ये सब करने की कोशिश कर रहे हैं, ऐसे noise आ रहा है. So by hearing this, by seeing this outcome, the professor will go mad. Okay, so you have achieved what I could not achieve in the last 30 years. He says, this is the evidence of Big Bang. Okay, so he will explain how this can be considered to be the evidence of Big Bang. उनको समझ भी नहीं आएगा. Okay, they are amateurs, मतलब अभी कॉलेज से बाहर आके ये सब कर रहे हैं. Okay, but उनको ये तो समझ आ गया कि they have done something important discovery. Okay, so they will make this ऐसे पूरा methodology को ऐसे एक paper बना के they will publish this paper. 10 years later they will get Nobel for this. And उस प्रोफेसर को कुछ नहीं मिला था. उनको बस पासिंग रिमार्क मिला था नोबेल देते समय, तो इनका भी कुछ हेल्प है ऐसा. बिकॉज दैट इज हाउ द नोबेल प्राइज इज गिवन. ओके, इट्स ओनली फॉर द प्रूफ. जो किया है, प्रूफ किया है, उन्हीं को ही मिलेगा. So what exactly is this radiation? That background noise is what is called as the cosmic microwave background. The cosmic microwave background is the background radiation which is present in the entire universe. It is present in the entire universe. You go to any part of the universe, you will find this background noise. It is not only that place. Not only America, you come to India, you will find it here. You will find it here. You go to moon, you will find it there. You go beyond the solar system, another part of the Milky Way galaxy, you will find it there. You go to other than outside Milky Way galaxy, you will find it there. In every inch of the universe is this radiation has filled. This background radiation is there in every inch of the universe, every part of the universe. This was discovered. And this kind of radiation filling the universe is possible only through the event of Big Bang. Only when the Big Bang had happened, it would have released this kind of radiation which has filled this entire universe, and now the universe is expanding. As the universe is expanding, this radiation is also expanding. The wavelength of the radiation is increasing. Initially, it was a very high energy radiation. Gradually, it has shifted. It has undergone red shift. Its wavelength has gradually increased. From a very high energy, it has come to right now at the microwave level. Gamma rays, X-rays, UV rays, visible, IR, micro. अभी micro level पे है. Gradually वो भी shift होते जा रहे. उसके बाद में radio तक चला जाएगा. The entire universe is filled with this radiation. You will find it in every part of the universe. This kind of background radiation is possible only because of Big Bang. So this proves Big Bang. ये हुआ था 1960s में. Then people started to take this theory seriously. तो evidence आ गया. After that, in 2010 and later, we conducted this experiment. Okay, CERN का experiment हुआ था, Large Hadron Collider, and that gives a very clear idea how the energy can get converted into mass, how the massless particles will gain mass. That also proves the Big Bang. Okay, now that is why Big Bang is the most widely accepted theory. Okay, So write this. Cosmic microwave background. First point. It is an evidence supporting Big Bang theory. It is an evidence supporting Big Bang theory. Next point. It refers to a faint uniform radiation. Faint. बहुत हल्का सा. Faint. Faint uniform radiation that permeates the entire universe. That permeates the entire universe. And originated after the Big Bang. Originated after the Big Bang. Next point. As the universe expands, these radiations have undergone redshift to microwave range. Redshift to microwave range. ये है Big Bang theory. So any doubts here? So next topic, life cycle of a star. Life cycle of a star. So in the context of Big Bang, I told you, so when the matter originated, matter attracts matter. It forms clouds, gaseous clouds, huge clouds of gas will be formed. From this gaseous clouds, the stars would originate. How exactly they would originate and what happens after the origin, how long it will continue. Okay, that is the life cycle of a star. So after the Big Bang, it became clear that matter originated. Okay, the initial matter was all the lightest form of matter, that is hydrogen and helium. Majority of it is hydrogen only. Okay, so it resulted in the formation of huge clouds of hydrogen, huge clouds of hydrogen gas, gaseous clouds. And why they are together? Because of the gravity. Because of the gravity, it forms a huge cloud which remains as a single body. This huge cloud of gas, mainly made up of hydrogen, from where the stars would originate, is what is called as a stellar nebula. Nebula refers to gaseous cloud. Stellar nebula refers to gaseous clouds from where the stars would originate. Okay, it has to be very, very big in size. Okay, it has to be of a very high temperature. तब भी वहां पर उसके अंदर से stars originate हो सकता है. Stars can originate in a very big sized gaseous clouds with high temperature. Why the temperature is high here? Because of collision, because of friction. The atoms inside this gaseous cloud, they collide with each other because of the gravity. Okay, because of the gravity, they continuously collide with each other. They get attracted by the gravity. As the gravity pulls them towards each other, they collide and friction produces the heat. And as heat is produced, they get more energized and they start to move faster. As they move faster, more collision happens, more energy is released. That is how continuously it is producing heat. It is continuously producing heat and radiation, but it is not producing light. The light which comes from a star, that is a different light. It's continuously producing heat and radiations. But over a period of time, because of this continuous collision, the temperature of this gaseous body is increasing continuously. It is increasing. In which part of this gaseous cloud the temperature will be high? Central part. Because at the center there is more mass, more collision, more frequent collision, more heat is released. Okay, because of the higher gravity, there is more heat released. So temperature at the center is continuously increasing. After sufficient period of time, this gaseous cloud, initially it is just a gaseous cloud, over a period of time it becomes a body with a very clearly identifiable core. A big sized gaseous body with a very clearly identifiable core, which has a hot temperature than the surrounding area and whose temperature is continuously increasing. This intermediate body is what is called as protostar. इसका नाम है protostar. That is before star. Body which is there before the star. From stellar nebula, it gets converted into a protostar. Okay, so the difference is here there is a very clearly identifiable core of very, very high temperature and it is continuously increasing. Okay, the temperature is continuously increasing. When the temperature crosses a particular critical limit, a certain limit is there. Once it crosses that particular limit, that limit is 15 million degrees Celsius. Once it crosses this limit, it will get converted into a star. That is when we say a star is born. Why? What is the use of this high temperature? It is only at this high temperature two atoms of hydrogen can fuse together to form one atom of helium and releases huge amount of energy. This process is called as nuclear fusion reaction. अभी तक fusion reaction नहीं हो रहा है because of the friction, because of the impact only the heat is being produced. Now the fusion reaction will release the heat and radiation and that produces light. So what is this fusion reaction? Two atoms of hydrogen, the lightest atoms of hydrogen will merge together to form one atom of helium. Next heavier atom. Okay, so it forms one atom of helium. Everything is same. Okay, except there is a minute difference in mass. There is a very, very minute difference in mass. You compare to one atom of helium and two atoms of hydrogen, there is a small difference in mass. What happened to this mass? It got converted into energy. The same energy which got converted into mass during the Big Bang. Now the mass will get converted into energy. It releases a very, very high amount of energy. This energy is hidden inside the atom. It is hidden inside the mass. You convert a small mass into energy, it releases so much of energy. Now this energy is so high, this will create further chain reactions fusing multiple atoms of hydrogen into helium. It releases so much of energy, it will trigger a chain reaction of fusing multiple atoms of hydrogen into helium. That will further release much higher amount of energy. That will fuse thousands of atoms. Like this, the chain reaction continues. Once this process happens, that is what we call it as star. Star is a body which is producing light at its core through nuclear fusion reaction. तभी हम बोलेंगे इसको star. Now a star is born. What happens to this star? Can a star exist forever? No. As long as there is a hydrogen in the star, then only it can continue as a star. But hydrogen is continuously getting converted into helium. There is a limit to it. Of course, there is a huge amount of hydrogen, but there is still always there is a limit. For few thousand million years, it will burn. For few thousand million years, it will continue in this stage. After that, the hydrogen is completely exhausted. Hydrogen is converted into helium. Helium is also converted into much heavier atoms. Now there is nothing left at the core. Core is completely empty, almost empty. Now it enters the next stage, which is called as red giant. When it exhausts its hydrogen in the core, the hydrogen which is left in the peripheral area will start to undergo fusion reaction. The fusion reaction will now spread to the peripheral areas. Okay, so the peripheral areas, the surrounding areas will start to undergo fusion. Here. As long as the fusion is happening at the core, the body is stable. Okay, because whenever there is a fusion reaction, it releases so much of energy and that causes the body to expand. There is a tendency of expansion. Okay, so as the body tends to expand, there is a tendency to contract also. Once the core is trying to release this energy, from the core there is a tendency of expansion, but from outer side there is a tendency of contraction. There is a balance here. But if the peripheral area is trying to expand and core is contracting, this is opposite. The body becomes very, very big in size because the peripheral areas is expanding, right? That is why this body is much higher in terms of size, much bigger in terms of size. That is why it is called as red giant. It's a giant. Okay, but this body will not produce the light as that of a star. A star jitna bright nahi ho sakta hai. This cannot be as bright as star. It produces slightly dull light, thoda sa dim दिखता है. Therefore it is red. बहुत bright है जैसे हमारा sun है ना, so that is why it is usually shown in terms of yellow color, very bright. ये red में आ गया. It's a red giant. A red giant is a body which is like it has entered the next stage from a star. But however, even the peripheral areas also, the hydrogen is exhausting. However, this body is not a very stable body. The core is contracting at a very high rate. The peripheral areas are expanding at a very high rate. There is a tension created between the outer part and inner part. Outer part is trying to expand, inner part is trying to contract. This tension will cause the entire body to collapse after some time. It totally collapses. The outer shell collapses. That is what is a planetary nebula. A collapsed red giant is called as planetary nebula. It still has a core which is very dense, made up of these denser elements, and it is still producing some faint light. बहुत हल्का सा light आ रहा है इससे. However, the outermost part is everything is collapsed. That is what is called as planetary nebula, and it has nothing to do with the planet. Don't think it will produce planet. वो तो नहीं होता है. Okay, by mistake they have kept the name planetary nebula. It is not related to planet. When it was discovered for the first time, it appeared like a planet from a distance. They called it as planetary nebula. It is not related to planets as such. A planetary nebula will get converted into white dwarf after some time because the outer shell, once it collapses, there is no strength in it, there is no mechanism to hold it back, it gets removed over a period of time. Only the core will be left. That leftover core is what is called as white dwarf. The leftover core is called as white dwarf. White dwarf is a very small body from the original star. That is why it is dwarf. And it produces a very faint light. बहुत हल्का सा light आता है. Very difficult to notice, but you can still notice. After some time, even this light stops coming. That is when this white dwarf enters the next stage. That is black dwarf. जब पूरा light बंद हो गया, तो फिर हो जाते black dwarf. So why there is no black dwarf here? यहाँ पर क्यों नहीं बनाए हैं? क्योंकि black dwarf नहीं दिखता है. Okay, so you can literally not see a black dwarf. It is not possible. Okay, so we have not discovered any black dwarf yet. Okay, that is the final stage of this life cycle. From stellar nebula, the next one is protostar, protostar to star, star to red giant to planetary nebula to white dwarf to black dwarf. This is the normal life cycle of a star when it is an average star. Okay, what is an average star? Any star with the mass of less than 10 times the sun. Any star with the mass of less than 10 times the sun is called as average star. Matlab, up to 10 times the size of sun is called as average star. More than 10 times the sun, it is called as massive star. मतलब इमेजिन करो सन कितना छोटा स्टार है. सन इज कॉल्ड एज ए ड्वार्फ स्टार. ओके, सन इज कॉल्ड एज ए ड्वार्फ स्टार. बहुत छोटा सा स्टार है. अप टू 10 टाइम्स इट इज कॉल्ड एज ए नॉर्मल स्टार. once the mass is more than 10 times, it is called as a massive star. A massive star will take a different life cycle because there is a very high mass. Okay, totally इसका कहानी अलग हो जाता है. पहले ये क्लियर है? ठीक है, so write about this. Leave some space for this flow chart if at all you have not drawn. Okay, तो इसको बाद में ऐड कर देना. So write about this briefly, quickly. First one, stellar nebula. It is a giant cloud of gas and dust. A giant cloud of gas and dust. Mainly made up of a giant cloud of gas and dust. Mainly made up of hydrogen. Full stop. The gaseous particles collide. The gaseous particles collide due to gravity. Collide due to gravity. And the entire nebula starts to spin. Entire nebula starts to spin. Next point. Starts to spin. Spin. Rotate. Starts to rotate. Next point. Protostar is a spinning gaseous mass. Protostar is a spinning gaseous mass with a hot core. Spinning gaseous mass with a hot core due to the heat released during the collision of gaseous particles. During the collision of gaseous particles. Next point. When the temperature of protostar's core reaches 15 million degrees Celsius. Reaches 15 million degrees Celsius. Nuclear fusion reaction begins at the center resulting in birth of a star. Next, red giant. Red giant is the next stage of star. Red giant is the next stage of star. When the supply of hydrogen runs out. When the supply of hydrogen runs out. Stop. The core starts to contract. The core starts to contract and simultaneously and simultaneously outer shell expands. Simultaneously outer shell expands. Resulting in a very big size, of the body. So how big it can become? कितना बड़ा हो सकता है? Our sun is a normal star. Our sun ends up through this life cycle only. It finally ends up being a white dwarf and black dwarf. ठीक है? Our sun is in this stage of star. It has gone through this stage of star for 4.6 billion years. 4.6 billion years is the age of our sun. It will be there in this stage for the next 7 billion years. Up to next 7 billion years, it is going to be a star only. After that, it becomes a red giant. When it becomes a red giant, the sun becomes so big. It becomes so big that it will consume Venus and Mercury both. इतना बड़ा हो जाएगा. Then Earth will be the first planet. The future of the Earth is not very clear. It may also get consumed. That is 7 billion years in the future. Don't worry about that. तब तक हम नहीं रहेंगे. Next one. Planetary nebula. When a low mass star with less than 10 times the mass of sun, becomes a red giant, its core collapses. And leads to the formation of planetary nebula. Which is a spherical shell of gases. So next, white dwarf. A planetary nebula will gradually be left with the core inside the shell. Which is called as white dwarf. So a white dwarf becomes a black dwarf. Over a long period of time. So now the other life cycle. Yes. Source of? See, the reactions are still going on. So other than the fusion reaction, few other reactions would happen at the core. That produces a very faint light. That is not equivalent to the normal light produced by the star. Okay, very light radiations are coming out. That is sufficient to observe. But even that will stop after some time. Then it becomes a black dwarf. That is why black dwarf is not possible to be discovered right now. We don't have a method to discover the black dwarf. We have not discovered any black dwarf. It is just a theory. Okay, theoretically it should be existing. There are, yes, there are many other reactions happening inside the stars other than the fusion reaction. So if the mass of the star is more than 10 times the sun, it results in, it is what is called as a massive star. For a massive star's formation, the initial nebula should also be massive. The initial nebula should also be very, very big in size. Whenever the initial nebula is very, very big in size, it results in the formation of a massive star. A massive star, because of its high mass, high density, high gravity, it takes a different life cycle only. A massive star, once it exhausts its fuel, it becomes a red supergiant. A red supergiant is a much, much bigger body than a red giant. It's a red supergiant. Red supergiant is such a big body, and there is a strong tension. Okay, there is a strong pull outward as well as inward. The central part, because of high mass, okay, because after the nuclear fusion reaction, whatever the elements which are left, they are all high density element. Okay, so and they are all having a very high gravity, and that is causing the entire body to collapse continuously. At the same time, there is a strong pull outwards. Because of this high tension, the entire body explodes. The entire body explodes very, very violently. That explosion is what is called as supernova explosion. The explosion of red supergiant is what is called as supernova explosion. It is just an event. Okay, but this is a very, very violent explosion. The most violent explosion which we have observed in the universe, because Big Bang we have not observed. The most violent explosion we have observed in the universe is supernova explosion. It is so violent that if it happens, it can be visible even in the day sky also. Daytime you cannot see any stars, nothing. The sun is so bright, but you can see supernova if it occurs. That is supernova explosion. Supernova explosion is so violent, it releases huge amount of energy. It releases huge amount of energy. How much of energy? At that moment, wherever supernova explosion is happening, it may be happening inside a galaxy. Let's say Milky Way galaxy के अंदर supernova explosion हो रहा है. Okay, there are 100 to 400 billion stars inside the Milky Way galaxy, right? In that, let's say one is undergoing supernova explosion. That one supernova explosion releases the amount of energy equivalent to the entire galaxy at that time. One supernova explosion releases the energy equivalent to the amount of energy released by the entire galaxy at that time. That is, one supernova explosion is equal to the light released by 100 to 400 billion stars. It is such a violent explosion. Most of the elements, most of the matter in the universe is all lighter in nature. The most abundant element is hydrogen. Okay, all of them, most of the element which is present in the universe is all lighter. How did the heavier elements come into picture? The fusion reaction will cause to some extent the heavier elements, but heavier elements, very heavy elements cannot be produced inside the star. They are produced during the supernova explosion. The energy is so high that it can cause the two heavier atoms to fuse together to produce much heavier atoms. Most of the heavier atoms are produced during the supernova explosions only, but they are still very, very limited. Okay? That is supernova explosion. When supernova explosion happens, most of the star collapses. It will not be left with anything. But some of the massive stars are so massive, even after supernova explosion, the body is still there at the core. Even after the supernova explosion, there is a core left. If that core left is between 1.4 to 3 times the sun, मतलब ये बता रहा हूं मैं, after the explosion इतना सा mass बचा है. After the explosion, if the mass left is between 1.4 to 3 times the sun, it becomes a neutron star. If it is more than 3 times the sun, that is when it becomes a black hole. Less than 1.4, it will not survive. Okay? It has to be minimum 1.4 to 3 times the sun. After the explosion, if that much of mass is left, it becomes a neutron star. If more than 3 times the mass of sun is left even after the supernova explosion, it becomes a black hole. Now what is a neutron star? A neutron star is a very small body, very densely packed mass it has. It has the mass equivalent to 1.4 to 3 times the sun. 1.4 to 3 times the sun is packed in a very close space, and most of them are neutrons only. Most of the mass is just neutron only. That is why it is called as neutron star. It is made up of closely packed neutrons, very small body, a very, very high dense. Okay, so it's so high, the density is so high in this. You pick up 1 spoon of matter from this neutron star, एक चम्मच का matter उठा लो, that 1 spoon of matter is equal to 500 billion kgs. 500 billion kgs is the matter you will get it. That high density matter. Okay, some of these neutron stars start to spin at a very high speed. That is what we call it as pulsar. पल्सार सुना है, बहुत स्ट्रांगली ऐसे घूमता है, तो फिर वो वहाँ पर आएगा, थोड़ा सा उसका लाइफ साइकिल थोड़ा कंटिन्यू होता है. हमारे लिए इतना तक काफ़ी. न्यूट्रॉन स्टार रह गया, फिर वो खत्म हो जाता है. न्यूट्रॉन स्टार होके फिर पल्सार होके फिर आगे जाके खत्म हो जाएगा. If the mass left is more than 3 times the mass of sun and it is closely packed in a very, very small space, okay, so of course then only it will survive. बहुत बड़ा सा डिस्ट्रीब्यूट है तो वो सर्वाइव नहीं हो पाएगा. The high density body closely packed, the mass which is equal to more than 3 times the sun, the entire body now starts to collapse under its own gravity. The gravity becomes so high that it will start to shrink continuously. It will start to shrink, and over a period of time it becomes a black hole. What is a black hole? Black hole is not a hole. Don't think it's a hole. If people think it's a hole जहाँ से कोई light बाहर नहीं आ रहा है. Black hole is a body. Black hole is a body. There is a body at the center with the mass more than the sun, 3 times the sun. That much of mass is concentrated in a very, very small space. इतना small space में 3 times the mass of sun is concentrated. It is almost equivalent to infinite density. The density is almost infinite. It is infinite density, infinite gravity. A body with infinite density, infinite gravity, we have no other word other than singularity. Big Bang के अंदर जो था उसको भी singularity बोला हमने, इसको भी singularity बोलेंगे. Because we have no idea at all beyond this. Okay, there is a very high density body at the center and it is continuously collapsing. It is so dense, so high gravity is there that even the light which is coming out through is not able to come out. The light is also not able to escape its gravity. Okay, so you cannot stop light. That is what is happening in the sun. The light comes out. Okay, so powerful that it has a tendency of expansion. In the black hole, even the light is held back. There's that high amount of gravity. Now beyond this is area which we don't know about yet. इसके बारे में ज़्यादा कुछ हमें पता नहीं है. So there are just hypotheses. Einstein had spoken about black holes. Okay, so Stephen Hawking had spoken about black holes, but very recently only we have got the picture of a black hole that proves the existence of black hole. Okay, अभी तक तो वो theory था, अभी तो with a picture they captured a picture. Okay, image एक capture किया था, तो उसके through हमने prove कर दिया black holes है. Because you cannot see a black hole, it's a black hole. The light is not coming out. है ना? Then how did they picture this? इसको picture कैसे किया? There is a limit up to which this infinite gravity functions. Okay, infinite gravity का जो area है ना, एक particular limit तक होता है. Okay, so once you cross that area, the light can pass through that. इसके पीछे से या peripheral area से कोई radiations आ रहे तो फिर वहां से आएगा वो radiation. Center से तो बिल्कुल zero. It is totally black. By observing that continuous radiation coming from the event horizon, it's called as event horizon. वहाँ से रेडिएशन कलेक्ट करते करते ओवर ए पीरियड ऑफ टाइम 2 to 3 years वो लोग कलेक्ट किए थे. ओके, सो इन अंटार्कटिका ऑब्जर्वेटरी में बना के वहाँ पर कलेक्ट किया. देन दे केम टुगेदर, देन ओके दे मेड ए ह्यूज एफर्ट. मतलब इतना 2-3 साल लग गया था वो डेटा को समराइज करने में. ओके, सो एंड टू एनालाइज एंड देन डेवलप ए इमेज आउट ऑफ दिस. इनफैक्ट स्टीफन हॉकिंग वाज आल्सो इन्वॉल्वड इन दिस प्रोजेक्ट. Okay, but before they could come out with the image, he died. Okay, so I've been very happy if at all he had got to know that they were able to capture the image. Okay, because that proves his theories, that proves the Einstein's theories of existence of black holes. Because black hole is something which is रियली ब्लैक होल फॉर अस, क्योंकि हमें कुछ ज़्यादा पता नहीं है व्हाट एग्जिस्ट बिहाइंड ब्लैक होल, व्हाट इज द नेचर ऑफ सिंगुलैरिटी। ओके, इसके बारे में ज़्यादा कुछ पता ही नहीं। देर आर हाइपोथेसिस विच सेज दैट बिहाइंड ब्लैक होल देर इज अ वाइट होल, लाइट यहाँ से जाएगा वहाँ से बाहर आएगा। Okay, and there is also a hypothesis that this is the same singularity which becomes Big Bang later. है ना, हो भी सकता है, तो पता नहीं। we all this is beyond our knowledge, beyond our capacity, है ना। So the closest approximation of a black hole is shown in the movie of Interstellar. Interstellar का climax में जो दिखाया था ना, that is the closest approximation. वो 2013 में आया था इंटरस्टेलर, 13 या 14 में आया था ना। इमेज तो रिसेंटली लिया था, आई थिंक दैट वाज इन 19 और 20 दे कैप्चर्ड द इमेज, दैट वाज ऑलमोस्ट सिमिलर। ठीक है, दैट प्रूव्स यस ब्लैक होल्स आर देयर, द इमेज प्रूव्स द ब्लैक होल्स आर देयर, एंड ब्लैक होल्स प्रूव्स दैट दिस साइकिल इज आल्सो राइट। ठीक है, this is the life cycle of a massive star. Whenever the mass of a star is more than 10 times the sun, it becomes a massive star. Massive star becomes red supergiant, sorry. Red supergiant explodes to become supernova explosion. After the explosion, if the mass left is between 1.4 to 3 times the mass of sun, it becomes a neutron star. If it is more than the 3 times the mass of sun, it becomes black hole. This limit is what is called as Chandrasekhar's limit. Okay, the limit given by an Indian scientist Chandrasekhar, इसलिए नाम रखा है Chandrasekhar's limit, 1.4 to 3 times का जो लिमिट है। ठीक है, चलो राइट अबाउट दिस। कंटिन्यू, नेक्स्ट वन, रेड सुपर जायंट, उसी में कंटिन्यू करो। रेड सुपर जायंट, if the mass of star is more than 10 times the sun, the mass of star is more than 10 times the sun, it results in the formation of red supergiant. It results in the formation of red supergiant. Next, supernova. A red supergiant, a red supergiant gradually lead to supernova explosion. Supernova explosion. Due to the explosion of core. Due to the explosion of core. Next point. Supernova is a very violent explosion. उसी के अंदर, supernova के अंदर. Supernova is a very violent explosion. Releasing huge amount of energy. Okay, supernova में इतना सारा सा एनर्जी रिलीज होके आता है, if anywhere within 10 light years from the earth, 10 light year is the distance traveled, 1 light year is the distance traveled by light in 1 year, 10 light year is the distance traveled by light in 10 year. मतलब लाइट का स्पीड तो पता है, द फास्टेस्ट 3 into 10 to the power 8 मीटर पर सेकेंड, उस स्पीड में 10 साल तक जा रहे, उतना जितना दूर हो सकता है। अगर इतना पेरीमीटर में, इतना रेडियस एरिया में कहीं पे भी सुपरनोवा एक्सप्लोजन हुआ तो हम खत्म हो जाएंगे. Okay, so the life on the earth will come to end if anywhere within the 10 light years the supernova explosion happens. Is it possible? Is it possible? हो सकता है? Yes or no? सन तो क्या, सन कितना डिस्टेंस है? What is the distance between sun and earth? 10 light year कितना डिस्टेंस है? Can you imagine 10 light year? Light year is the light traveling in 1 year. The light takes 8 minutes to reach from sun to earth. Okay, so 1 year का डिस्टेंस सोच लो, 10 year का डिस्टेंस सोच लो. Okay, so हो सकता है? नहीं, नहीं है. There are no massive stars in the nearby vicinity, luckily. Okay, so up to 50,000 light years there are no massive stars. नहीं है. Okay, what is the nearest star? Proxima Centauri. How far is Proxima Centauri? 4.3 light years. Okay, so 4.3 light years is the distance between Proxima Centauri and the sun. So let's say if Proxima Centauri undergoes supernova, obviously the life on the earth will come to an end. But when? After 4.3 years. Because it will take 4.3 years for that light to come towards the earth, right? Supernova हुआ है, वो लाइट आने में 4.3 years लगेगा ना. So 4.3 years में हम निकल सकते हैं? बिल्कुल नहीं. Because who will travel faster than light to come and tell us that there is supernova in Proxima Centauri? Because the Proxima Centauri which you are seeing today is 4.3 years old. Is that right? You will get to know about the supernova after 4.3 years. अगर आज सुपरनोवा हो गया प्रॉक्सिमा सेंटारी में, 4.3 years के बाद में हमें पता चलेगा. जब पता चलेगा तब भी खत्म. Okay, so that is the idea, right? So the stars which we see in the night sky is not the stars which is existing right now. Okay, so I was telling earlier, it is not live, it is recorded video. Okay, so game तो पहले हो गया, हम recording देख रहे हैं बस. It may be 1 year old, 2 year old, 100 year old, 1000 year old, or a million-year old, depending upon the distance. जितना distance होगा उतना पुराना वीडियो है वो. Many of the times the star is non-existing right now. वो स्टार खत्म हो गया, सुपरनोवा हो गया, ब्लैक होल भी हो गया, हम बस स्टार देख रहे हैं अभी. बिकॉज उतना टाइम लगेगा ना वो लाइट आने में, राइट? सो कंटिन्यू. दैट वाज सुपरनोवा. सुपरनोवा क्या लिखा था लास्ट? रिलीजेस वेरी हाई अमाउंट ऑफ एनर्जी. ठीक है. नेक्स्ट, न्यूट्रॉन स्टार. After supernova explosion, if the remnant core is between, if the remnant core is between 1.4 to 3 times the mass of sun, remnant core is between 1.4 to 3 times the mass of sun, it results in neutron star. It results in neutron star. Which is a body made up of, very closely packed neutrons. A body made up of very closely packed neutrons. Next, black hole. If the remnant core if the remnant core after the explosion is more than 3 times the mass of sun. It's more than 3 times the mass of sun. The core collapses. The core collapses under gravity. The core collapses under gravity, resulting in black hole. Resulting in black hole. First off, the core of a black hole. The core of a black hole is called as singularity. Core of a black hole is called as singularity. With infinite gravity and density. With infinite gravity and density. So next topic, galaxies and stars. Which mission? NASA का mission है. Are we working? There are many missions. बहुत सारा है. हो सकता है. ये सब आप देख लें, करंट अफेयर से देख लो, बहुत सारा मिशन मिलेगा. I'm just giving you introduction. We would need these terms for geography. I'm just introducing that. Okay, all of this will be covered in your current affairs, science and tech. वहाँ से cover होगा. ठीक है? किस वन? हो सकता है. Okay, so जो black hole का picture हमने लिया था, first black hole to be captured was M87. M87 was the name of the first black hole to be pictured. ठीक है. सो देखो, ये सब तो इसमें बहुत सारा डिटेल में आपको पढ़ना है. यू हैव टू गो थ्रू मच मोर डिटेल मैनर. तो ये सब आप करंट अफेयर्स और साइंस एंड टेक क्लास से ही कवर करोगे. ओके, आई एम नॉट गोइंग टू टच एनी ऑफ दीज मिशंस, प्रोग्राम्स, ओके, स्पेस लॉन्चर्स जो भी होगा, आई एम नॉट गोइंग टू टच इनटू दैट. दिस इज जस्ट अ वेरी बेसिक आइडिया ऑफ द कॉस्मोलॉजी विच इज रिक्वायर्ड फॉर जियोग्राफी. बताइए, व्हाट इज अ गैलेक्सी? गैलेक्सी क्या होता है? ग्रुप ऑफ स्टार्स. अभी तो देखा स्टार तो बस वन टाइप ऑफ बॉडी. व्हाट अबाउट अदर बॉडीज? वो सब हमने इग्नोर कर दिया. इतने सारे बॉडीज हैं. यस, इट्स नॉट जस्ट स्टार. लार्ज ग्रुप ऑफ stars, nebulas, red giants, okay, so black holes, all of them together. Okay, so it's a large group of all these bodies together existing as a single system. It includes stars, gaseous nebulas, okay, so and the red giants, white dwarf, planetary nebula, black holes, neutron star, ऐसे बहुत सारा सारा मिला के एक सिस्टम बनता है. That is what is called as a galaxy. Okay, it's a sprawling system. से स्प्रेड हुआ है, स्प्रॉलिंग सिस्टम. A sprawling system of made up of all these bodies together. That is one galaxy. Okay, there are 100 to 400 billion such galaxies in the universe, as far as we know, जितना हमें पता है. And that too, between two galaxies, there's a huge space, unimaginable amount of space between two galaxies. What holds all these bodies together as a single system? Why they have to exist together as a single system? Is gravity of each other? Is it the gravity of each other which is holding them together? Is it sufficient to hold them together? Let's say in the solar system you remove sun from the picture. Can all the planets exist together as a system? And what is holding these bodies inside the galaxy? A supermassive black hole. At the center of every galaxy, there will be a supermassive black hole. Black hole, massive black hole, supermassive black hole. The largest possible black hole. The largest category. The very, very big sized black holes. Okay, they are basically formed by the merger of multiple black holes. Over a period of time, it grows in size. Okay, so at the center of every galaxy, there will be a supermassive black hole. And the gravity of this supermassive black hole holds all the bodies together. 100 to 400 billion stars and other bodies. Okay, stars के साथ में इतने सारा bodies है ना, so red giants ले लो, white dwarf ले लो, black dwarf ले लो, सहारा मिला के सबको hold करके रखा है. And there's a huge amount of black, dark matter, dark energy, सारा मिला के एक system बनता है. That one system is what is called as a galaxy. ठीक है? There are three types of galaxies, three categories of galaxies. One is spiral galaxy, spiraling shape. Spiral galaxy. Second one is elliptical galaxy. Third one is irregular shape. A spiral galaxy has a spiral shape. Spiral shape basically means it has a central dense cluster of stars. From this, the spiral bands come out like this. Okay, bands of stars come out. Okay, these stars are arranged in certain bands. If you see from one side, it appears like this. इसका side view कैसे दिखेगा? It appears like a disc, the bulge at the center. Okay, ऐसे. It appears like a disc. ऊपर से देखो ऐसे, ऐसे spiraling system. इसको side से देखो ऐसे. This is the spiral galaxy from the top view. This is the side view. ऐसे disc. This is how spiral galaxy is there. At the center of this, there is a supermassive black hole. वो कहाँ दिखेगा? वो नहीं दिखेगा. Because a galaxy is a very, very big sized body. गैलेक्सी इतना बड़ा सा बॉडी है कि यू कैन नॉट सी दिस सुपरमैसिव ब्लैक होल. वो सेंटर में है. जैसे हमारा सोलर सिस्टम है. सोलर सिस्टम को पूरा साइज लेके आओ, सन भी नहीं दिखेगा आपको. सन भी इनविजिबल हो जाता है. Okay, but it is capable of exerting its gravity on all these bodies. This kind of galaxy is spiral galaxy. Best example is Milky Way galaxy. Other than Milky Way galaxy, Andromeda galaxy. Andromeda is also spiral galaxy. Andromeda is the nearest galaxy to the Milky Way galaxy. Okay. Second one is elliptical galaxy. Elliptical galaxy is like spherical shape. Perfectly spherical तो नहीं होगा, इसलिए oval बन जाता है. That is why it is elliptical. Okay, where the stars are uniformly distributed. Okay, so ऐसे uniformly distributed है. That kind of galaxy is called as elliptical galaxy. Third, irregular pattern, irregular galaxy. Three types of galaxies. ठीक है? So write about this. Overall topic: galaxies and stars. Galaxies and stars. Subheading: galaxy. Galaxy is a sprawling system. Sprawling system of gas, dust, dark matter, dark energy, stars, and other bodies. Stars and other bodies held together by gravity. Held together by gravity. So, at the center of every galaxy, at the center of every galaxy, there will be a supermassive black hole. There will be a supermassive black hole. So next subheading, types of galaxies. Types of galaxies. Number 1, spiral galaxy. With spiral arms. Spiral galaxy with spiral arms and relatively a flat disk. Relatively a flat disk with a central bulge. Relatively flat disk with a central bulge. Second, elliptical galaxy. Spherical or oval shaped. Spherical or oval shaped with stars distributed uniformly throughout. With stars distributed uniformly throughout. Third, irregular with no definite shape or structure. With no definite shape or structure. So next subheading, Milky Way galaxy. So लिखते जाओ. It is a spiral galaxy. Milky Way is spiral galaxy. हमारा galaxy है spiral galaxy. Why the name Milky Way? हिंदी में क्या बोलते हैं? आकाश गंगा. Why the name Milky Way? Okay, good. So when you see from the Earth's surface, it appears like a band of stars. The question is, can you see it from the Earth? Can you see our galaxy from the Earth? We are part of the galaxy. Being within the galaxy, can you see the galaxy? Yes, you can see. Because this is a spiral galaxy. You can see a part of spiral galaxy. पूरा नहीं देख सकते, एक part देख सकते हो. Like this. Most of you would have seen this picture. In fact, this wallpaper भी रखा होगा. बहुत अच्छा सा दिख रहा है बोल के. Without realizing this is the Milky Way galaxy. Of course, it is not visible everywhere every time. First of all, you should be able to see the stars very clearly. Okay, and you should be lucky. The orientation should come perfectly aligned. Okay, so the Milky Way galaxy being a band, by spiral shaped band, right? Okay, so Earth is there in one of the part of this. Okay, so if this is the central bulge, from here the different bands of stars are originating and moving like this. Okay, so one band in which the sun is located, let's say this is the band in which sun is located. What is this band called as? What is this arm called as? Orion. Orion is the name of that arm. Milky Way galaxy का जिस गली में हम रहते हैं उसका नाम है Orion. In Orion, one of the star is sun. उसके around Earth भी है. Earth is located in the Orion. Okay, so the sun, along with the other stars, every body is taking a revolution around the Milky Way galaxy. The entire structure is moving. The sun is continuously moving around the Milky Way galaxy. Every body is moving around the Milky Way galaxy. This motion is what is called as the galactic motion. Okay, so if sun is moving, obviously Earth is also going. जहाँ पर sun जाएंगे उसके पीछे हम भी जाएंगे. Okay, और कुछ option नहीं है. During its motion, so if the alignment is arranged in such a manner, of course you cannot see it like this, rather you can see it. Okay, मान लो यहाँ पर हमारा location है, if we are located somewhere here. Okay, so and if the earth is here somewhere, earth का orientation देखो, ऐसे surface के लिए perpendicularly मिल गया तो देख सकते हैं ना, you can see this particular part, surface है ऐसे. Very rarely you will be able to see this part. This band which appears like a patch of milk flowing down from the sky. Okay, so in our scriptures it is written, okay, it is flowing down from the sky as a. That is why Akash Ganga, the flowing water or flowing milk. That is why the name Milky Way. Okay, it is visible only from a very rare occasions, only from the regions where the sky is very clear, where there is no light pollution, where there is no air pollution and dust pollution. That means you should be definitely out of Delhi. Okay, तभी ये देख सकते हैं, best place in India to see this is Ladakh. Okay, Ladakh, the best place not only in India, in the entire world, one of the best place to see for the stargazing. People from across the world come to Ladakh. Okay, people from India, we go to Ladakh for bike riding. Okay, so to go to Pangong So Lake and take picture on that scooter which is kept there by 3 idiots. है ना, वहाँ पर वो फोटो खींच के आते हैं. बट पीपल फ्रॉम अक्रॉस द वर्ल्ड दे कम टू लद्दाख. कहाँ पर? यस, व्हाट इज द प्लेस? स्पीति वैली इज इन हिमाचल. वहाँ पर भी क्लैरिटी दिखता है, बट द बेस्ट लोकेशन इज इन लद्दाख. Is this part of Ladakh, the southeast corner of Ladakh. In this place there is a location called as Hanley. Hanley, Hanley. Okay, this is the best place. Across the world people come to Leh and then they travel here. Okay, they wait here for stargazing. Hanley. This has been recently declared as the dark sky reserve of India. ठीक है, एंड यहाँ पर बेस्ट लोकेशन है. एंड ये पूरा एरिया में आपको बहुत क्लियर मिलता है. इसीलिए ये जो हिमाचल का जो पार्ट है ना, दिस पार्ट ऑफ हिमाचल, दिस इज व्हाट इज द लाहौल स्पीति वैली. दिस इज आल्सो वन ऑफ द बेस्ट लोकेशन. हियर आल्सो देयर इज अ वेरी क्लियर व्यू. ठीक है, सो लाइक दिस इन सर्टेन प्लेसेस यू कैन सी दिस very clearly, very easily. Otherwise it is very very difficult, and only for a particular time of the night. Okay, so maximum like some time, like if you are extremely lucky, maybe for the entire night you may be able to find it. and only in some few days in the year you'll be able to observe this, and that varies from one place to another. Okay, alag alag location mein alag alag time mein dikhta hai. This is what is Milky Way galaxy. Okay, so Milky Way galaxy is a example of spiral galaxy. Okay, so write this. Next point. The sun is located in the Orion arm. Orion arm, ARM, arm of Milky Way. Orion, Orion, Orion. Who is the neighbor of sun? Proxima Centauri. The nearest star to sun is Proxima Centauri, located at 4.3 light years from the sun. 4.3 light years from the sun. Nearby there is another star which is the brightest star of night sky. Sirius. Sirius is the brightest star of night sky. It is located at 8.6 light years. पास में ही वो भी ओरायन के अंदर ही है. Sirius. It is the brightest star of night sky. Is there any body in the night sky which is brighter than this? Of course, moon. Other than that, planets. The planets appear brighter than the star. And the supermassive black hole at the center of Milky Way galaxy is Sagittarius A. Sagittarius A is the supermassive black hole. At the center of Milky Way. The nearest galaxy to Milky Way is Andromeda. Andromeda is the nearest galaxy to Milky Way. Any of you have seen Andromeda galaxy? You can see in the night sky if you make an effort, if you are not in Delhi. Okay, so it appears like a small patch. Stars to dikhega. Okay, stars are visible. Okay, they twinkle. Okay, so in the night sky in particular direction, एक particular छोटा सा patch दिखता है. There is a small patch visible in the night sky. This patch. This is the Milky Way. इसके यहाँ पर ऐसे दिखता है. This patch is what is Andromeda galaxy. It is also a spiral galaxy. This is the nearest galaxy to Milky Way. You know, Andromeda is moving towards Milky Way. Both are moving towards each other. In 7 billion years in the future, both of them will collide with each other. What happens when they collide? What happens? Nothing happens. Literally nothing happens. Even if two galaxies collide with each other, it will not result in collision of two stars, because there is so much of space inside a galaxy. There is so much of space inside a galaxy, it can accommodate another galaxy. दोनों पास में आके मर्ज होके एक और बड़ा सा गैलेक्सी बन जाता है. There is so much of space inside one galaxy. ये तो idea of space is unimaginable for us. Okay, so for us everything is like the way we see things on the earth. No, in the universe, once you are in the space, it is difficult to imagine the space. There's so much of space in the Milky Way galaxy, it can fit another, you can fit another galaxy inside Milky Way galaxy. Of course, they influence each other. Their gravity will definitely influence each other. It helps in redistribution of the stars within the Milky Way galaxy, but it will not collide. There is a very rare chance that two stars will collide because of the distance. Okay, so why they are moving towards each other? But Big Bang should have caused them to move away from each other, right? Okay, that is why I said very rare occasions they also move towards each other. If they are closer towards each other, if they are close enough to cause their gravity to attract each other, then gravity becomes a stronger force than the Big Bang. Big Bang का जो expansion से ज़्यादा अगर stronger gravity आ गया, they will start to move towards each other. Gravity will overtake them. That is happening in the case of Andromeda and Milky Way. Okay. The overall mass, overall size of the supermassive black hole, the number of bodies present in the galaxy, all of this. Okay, so other than this, few other information. We have light year. What is the idea of light year? The distance traveled by light in 1 year. Why did we choose light as the unit of measuring distance? It is the fastest as well as it remains constant everywhere. Okay, that is the important thing. Okay, so write this. Light year is the distance traveled by light. Light year is the distance traveled by light in 1 year. In 1 year at the speed of 3 into 10 to the power 8 meter per second. So this question was asked in 2021. The speed of light is always the same. Okay. So let's talk about a phenomena which we have heard from our childhood. Twinkle, twinkle, little star. Why the stars twinkle? The basic difference between a star and a planet. I told you, in the night sky you will see stars also, planet also. Right? The basic difference between them is stars always twinkle. Planets don't twinkle. Okay, if you observe, have you observed any planets? If you observe them, they remain still. They don't twinkle. Stars twinkle. Why? Yes, one by one. Yes. Planets are not natural source. What is it with natural source, artificial source? Planets reflect the light from the sun. Stars have their own light. So reflected light क्या light दूसरा light हो जाता है क्या? वो भी तो light है. Why it will not twinkle? If it is not a direct source, why it will not twinkle? Give me the reason. Huh? Distance? So it will twinkle. So what is it with the artificial source or reflected light? उससे क्या लेने देने? It has no connection. It is not at all the reason. Reflected light twinkle नहीं होना है ऐसे कोई रूल नहीं है. वो भी twinkle हो सकता है. उसको ignore कर दो. That is out of picture. That is a wrong answer. Stars have their own light. Planets have reflected light. That is why there is no twinkle. वो गलत है. Then what is the reason? ठीक है, one by one. Reaction हो रहे कहाँ पर? Stars. Within the stars there are reactions. That is why we see the twinkling. No, we don't observe that. So what is your answer? Distance. How distance makes it to twinkle? Because of refraction. The light, when it passes through the atmosphere, it undergoes refraction. If a light coming from the star is undergoing refraction, why the light coming from the planet will not undergo refraction? So if they are comparatively nearer, what happens? Because of the simple fact that a star becomes a point source. What you are saying is right. Okay. When a light comes from a star, the light comes from a very, very far distance. It is located at such a far distance that it acts like a point source for us. What is a point? Point source क्या होता है? A single point. Light coming out from a single point is a point source. From a single point, if this is a single point, okay, so from a single point, whatever the light which comes out, it comes out only in one direction. यहाँ से ऐसे जाएगा, यहाँ से ऐसे जाएगा, यहाँ से ऐसे जाएगा. If the earth is here, it receives only one direction. मतलब एक ही, मतलब imagine it is just a single ray of light. That is what is point source. For us, star is a point source. For the same planet Earth, the other planets is not a point source. It's a non-point source. There is a bigger surface here. We will not be able to perceive this, but it is there. एक टेलीस्कोप ले लो, आपको बहुत क्लियरली दिख जाएगा. Okay, the planets are not point source. So therefore, what happens? The light coming from the star comes like a very narrow ray of light. It's a very, very narrow ray of light. Whereas light coming from a nearby planet comes like a beam of light. Okay, it's much, much wider and higher intensity. When this light passes through the atmosphere, it easily undergoes refraction and it is very clearly visible for us. ये हमारे लिए बहुत clearly visible हो जाते हैं. But if this light, when it passes through the atmosphere, obviously this will also undergo refraction. ऐसे नहीं कि it will not undergo refraction, but it is not like all of this will undergo refraction at the same time, right? If one part is undergoing refraction, another part is there next to it, it will just compensate. It will not be visible. The refraction of the light coming from a nearby planet is not very clearly visible because this is not a point source. The same light coming from a point source undergoes easy refraction and becomes very clearly visible. यहाँ पर भी refraction चल रहा है, but इतना intense light है. It is coming from a wider surface area. It will not be visible. एक part refraction हो रहा है तो दूसरी part उसको cover कर लेता है. Will not be able to see that. Atmosphere is not that dense कि it will make the entire light ray, entire all of them to undergo refraction at the same time. It is not possible. Therefore, this undergoes easy refraction. This will not undergo easily refraction. Even if it is undergoing, so it will not be visible. वो दिखेगा नहीं. That is why the stars always twinkle. That means if you go beyond the atmosphere and observe, none of them twinkle. Is that right? Yes. No twinkling is observed inside the sky, inside the space beyond the atmosphere. Once you cross the atmosphere, particularly lower atmosphere cross कर लो जहाँ पर density of gases बहुत high है, एक बार 100 किलोमीटर cross कर लो तो आपको twinkling दिखेगा या नहीं. You will not see the twinkling. ठीक है? It is observed only from the surface. This is the main difference between a star and planet. Stars always twinkle, planets do not twinkle. And no twinkling, neither star nor planet in the space. Okay, let's write this. Subheading, twinkling of stars. It is due to turbulence in atmosphere. It is due to turbulence in atmosphere. Light from a distant star which is acting as a point source. Is acting as a point source. undergoes refraction easily. Undergoes refraction easily. Stop. However, the light coming from a nearby planet, however, the light coming from a nearby planet or satellite do not twinkle as it is not a point source. As it is not a point source. Next point. Twinkling is not observed in space. Twinkling is not observed in space. So next, constellation. ये सारा वही स्टार्स गैलेक्सीज का टॉपिक ही है. सब हेडिंग लिखो constellation. What is a constellation? Group of stars is called as constellation. Can we call any group of stars as constellation? It should make a what kind of pattern? A fixed pattern, a recognizable pattern. Okay, so आज जो pattern दिखेगा कल नहीं रहा तो वो pattern नहीं रहेगा. Okay, so because so the position of every star changes. Because as the earth revolves around the sun, okay, so the orientation of different stars changes. But during this entire revolution, some of the stars always appears to be fixed together. I'm saying together, they don't remain fixed in the sky. Whenever you see these stars, they always appear together. Those लोग हैं. Okay, so best friends. It is not necessary that they have to be present in the same galaxy. अलग अलग हो सकता है. They may be moving away from each other, but for human scale that is not visible. In the human time scale it is not observable. So in the human time scale they remain constant. This fixed pattern of stars which are found in the night sky is what is called as constellation. One of the best example of constellation which can be easily recognized. Usually you can recognize this anywhere. Okay, sometimes you will see it from Delhi also. Galti se. That is Saptarishi Mandal, also called as Big Dipper. Have you seen it? Group of 7 stars, very easily noticeable. Okay, there are 7 stars which always appear together. ये हमेशा साथ में ही रहता है. Okay, so it forms a fixed pattern always. इसको कहीं भी देखो ये ऐसा ही दिखता है. Okay, so and again the pattern depends upon what is going on in your mind. Okay, if you are in a pensive mode, maybe it looks like a question mark for you. Or if you are in a joyful mode, maybe it looks like a kite. Okay, so or for a farmer, ऐसे हल जैसे दिखता है, right? So it always appears together. And in the night sky also, the position of every star changes in the night sky, right? Why? Why the position of every star changes in the night sky? Because the earth rotates. Okay, so it's not the movement of other bodies. It's the movement of the earth will change the orientation of every body in the sky. That is why the sun appears to be moving, the moon appears to be moving. In the same way, stars also appear to be moving. They also always change their position. As they change their position, as the earth rotates, their pattern also moves together. That is what is constellation. It has to remain the same. Whenever you see them, you will see them always together. For example, after some time in the night sky, if at all you are observing Big Dipper here, you give 3-4 hours of time, you come back and see Big Dipper would have moved from there to here. But now here also they appear together like this. Okay, its position has changed. So वहां से ऐसे आ गया, जो साथ में ही दिखता है हमेशा. That recognizable pattern is what is called as constellation. Human beings have recognized this many such constellations in the night sky. ये सब तो बहुत पहले किए थे हम सब लोग, ये सब भूल गए, अभी तो टाइम नहीं है हमारे पास, है ना. So we have the constellations recorded in the cave paintings of prehistoric times. Prehistoric times का cave paintings में भी recorded है constellations. Because we had shown that much of interest in the space, in the sky. अभी तो बहुत कम हो गया, बहुत लोग stars भी नहीं देखे होंगे. ठीक है, so it is constellation. A group of stars forming a recognizable pattern. Group of stars forming a recognizable pattern in the sky. It's called as constellation. Example, Big Dipper or Saptarishi Mandal. Big Dipper or Saptarishi Mandal. You know, if at all you are able to see the Milky Way galaxy. So this is how you will see the Milky Way galaxy. Okay, a very beautiful appearance of these stars. And this is a very special video. So where the videographer has made an attempt to capture Milky Way galaxy, at the same time also capture the rotation of Earth. In this video you can see the rotation of Earth. Is it possible? Yes. Okay, what he has done, he has fixed the camera oriented exactly with the Milky Way galaxy. Of course, as the Earth rotates, the orientation changes. He changed the position of the camera very regularly. At the same interval, he has changed the orientation and fixed the camera exactly with respect to Milky Way galaxy. So then you can notice the rotation of Earth. Like this. And of course, this is a time-lapse video. पूरा रात का है. So fast forward करके ऐसे वीडियो आए हैं. Okay, so now you can very clearly see it is not the stars, it is not the galaxies, not the sun, not the moon which is moving. It is the Earth itself which is moving, right? And this is the rotation of Earth, which we normally not able to notice this. Actually, everything in the space is fixed. It is the Earth rotation which is making them to appear like moving. And usually that is why, because of the light source. Can you see यहाँ पर इतना सारा light source है, तो इसलिए वहाँ पर दिखता ही नहीं है. देखो अभी बहुत मुश्किल से को देख सकते हैं. ठीक है, ठीक है. So that is about the Milky Way galaxy. There is one small topic left in galaxies and stars. So that is related to pole star. Okay, so we'll discuss that tomorrow. And after that we'll start with solar system. We'll talk about the origin of solar system and about the bodies of solar system. Okay, thank you.